Okay, so now let's talk a little bit more about this particular method call here. The contract will be honored. Specifically, we want to talk about when we are calling this particular, when we are making this particular method call, how do we tell if the contract is really honored? Okay, which means the obligation for the clients must be satisfied, and also the obligation for the supplier are also satisfied, and also they gain their benefits respectively. Okay, so now let me go back to here. Let me just mention one more thing. Later on, we're going to talk about the sign diagram as well. Let me just give you a little bit of idea about how you can visualize the client-supplier relationship. It's actually quite easy, okay? But we'll actually do this more formally also in a later lecture about the sign diagram as well. So now we know that for the clients, we know that it's going to be the microwave user. Let me put it here, okay? It's a microwave user. I'll say MU, microwave user, just save some time. And also we know that supplier is actually microwave, right? So supplier is actually the microwave. I'll just say M. And now to visualize the client-supplier relationship, we have to draw some arrow. And the way to draw this is like this. We are going to have a directed arrow that will point from clients to supplier. Okay, to draw it, it's going to be like a double line arrow over here. I'll be more precise about the notation later in the lecture, maybe lecture 3 or 4 later in the series. And whenever you draw this particular double line arrow, that means we have microwave user being the clients of the supplier. But now one more thing, you have to somehow put the context objects in, because context objects suggest who the supplier is, right? In this case, microwave. So now you have to put the context object in question over here. So that will be M. So now thinking this way, the fact that you have MU pointing to the direction of M tells you that MU, being the client, is using the service from M. And the way it does that is by creating a context object called M. So now this particular arrow over here is telling you, you actually got microwave, which is this class over here, the supplier class, and then you declare its type being M, which is over here, right? So that's exactly what you actually saw in the implementation code. So by the end of the lecture, which I'm going to talk about later about the sign diagram, every time when you actually, it goes either way. When you see implementation details like this, where you have method call and different classes, you should really know the corresponding diagram looks like this. And symmetrically, if I give you a design diagram without showing you any code like this, you should know in order to implement this particular design architecture for client supplier, you have to do such declaration of the variable. Okay, so it goes either way. Okay, that's something I want you to really understand. Okay, let's go back to the original question here. How can the contract be honored? In order to illustrate it, I'm just going to duplicate this diagram over here, and then I will just make it a little bit clean because it's already annotated, so I don't want to pollute it further. Let me put it here. Okay, so now we're going to talk about what does it really mean when a contract is actually honored. Okay, so that's something we're going to worry about it now. Okay, again, we're going to go to the method call that's in question. Okay, let me highlight it again. So this is the method call. Now, we already know who the supplier is and who the client is. We already know that. So now you have to know some more terminology here. So now let me draw the arrow. Right before we actually make this method call, right before it, you can think about it's immediately after we have turn on the power for the microwave, and also after we have locked the microwave. So right before we try to make this particular method call. So this is so-called pre-states. Pre-execution of the heat method. You can think of it. Okay, and then we symmetrically we have a post states, and you can imagine where I'm going to draw it. I'm going to draw it now. So now immediately after the method call over here, right after I call m dot heat, right after it is going to be a post states. Okay, so we got pre-states, we got post-states. So these are the immediate points of execution right before and right after this particular method call. Okay, so now in the pre-state and post-states, now we can talk about what does it really mean for the contracts to be honored. Okay, let's now go back to the slides. Let me just illustrate point by point. Right before the method call, which means we are now in the pre-states over here, in the pre-state, which is the green over here. You have to make sure the clients actually satisfy the obligation. So now in the pre-state over here, so that means the clients satisfy the obligations. And what are the obligations for the clients? Apparently, it m dot on should be true, and also m dot locked should also be true, right? Both of them should be true. We know that, and it seems like these two are already satisfied by these two, right? So now you can think about m dot power. M dot power is really meant to establish this particular obligation, right? And also m dot lock is also meant to establish this particular obligation. However, there's a third obligation for the pre-state for the clients, which will be the object should be non-explosive, right? And also this object obligation 1, obligation 2, and also number 3. The input objects over here, OBJ, should be non-explosive. However, as far as the current code is set up is concerned, okay, is this guaranteed? The answer is no, because immediately after we say m dot power and also m dot lock, we didn't have any additional check by the clients, which is a microwave user. They never check if their lunchbox or whatever they put into the microwave is actually non-explosive. So you can see the OBJ is directly assigned from something that's uncertain. So it's not guaranteed. This is non-explosive, right? So now this is not explicitly checked by the clients. Okay, that's something to know. And then after, okay, let me just go back to the slide, finish that part, and then we'll go to the post states. So you want to make sure the m dot on is true and also m dot lock is true, right? However, for the OBJ to be non-explosive, that's not something really guaranteed. So for you as a client, in order to really satisfy that particular pre-states obligation, you have to do some explicit check to make sure OBJ is not explosive. Only if it's not explosive can you then call m dot heat. Okay, let's go on. And then right after the method call, so OBJ is probably heated if it's not explosive. Okay, so the main message to really get from this particular example over here is to think about pre-states and also think about post states. So there are two different execution points before and after the method call, and think about what really has to be satisfied in order for the contract to be honored. Okay, and apparently there's a possibility that we cannot honor the contract, because if the client gives something that's explosive, then it would actually not satisfy the obligation. Okay, so if any of these fails, for example, if the object is actually explosive, or let's say the object is not explosive, however, if you put your lunchbox into the microwave, however, let's say, for example, right, I'll just give you one example. Let's say in the post states, given that, for example, let's say, I'll just say for example, right, just one example scenario, given that OBJ is non-explosive, but OBJ is still cold, which means it's actually not heated. In this case, we will know that this particular scenario over here, who should be blamed? Apparently the supplier, right? So this is one scenario where, okay, let me just make it very precise for you so you can also take some notes. So this scenario is supplier breaches the contracts. And symmetrically, as we just mentioned before, so now let's say this guy here, let's say if the object, the input, actually passed by the clients. In this particular scenario over here, if somehow it's actually it's actually not non-explosive, in that case, it would be the clients who actually breaches the contracts. Okay, so I think it's really worth detailing every single detail for this method call, so you can extrapolate some general case from this. Okay, so if there's a contract violation, if any of the obligation, either the client's obligation or the supplier's obligation is violated. Okay, so for example, if either, well, in this case, well, let's say, just talk about in general, if it's either the power is not on or it's not locked, of course, it will be the microwave user's fault, right? We talked about this already, just as a reinforcement. And also, if the object, the input, is actually not explosive, that's exactly this case over here. So whose fault is that? Of course, the client's. And also, one more thing to note, which we'll see later when we talk about encoding decide by contract at the runtime. So if the clients, let's say this, let me just illustrate that point here. Whenever there's anything, let me just use another color here. Let's say the pre-state, right? So now you can think about the pre-state always checks. Basically, the pre-state refers to right before the method is called. Okay. So now in the pre-states, if the contracts is violated, and more precisely by the clients, the method call is not executed. Basically, think about if the client doesn't really even bother to actually give you something that's non-explosive. Of course, we don't even bother to actually execute the heap method. Okay, so that's something you will see later at the runtime if the precondition, well, in this case, well, I'm just going a little bit like a preview of what we're going to talk about. So in the pre-state, we check for precondition. If the precondition is already violated by the clients, then we don't really execute the method. We simply just signal an error about a breach of contracts. Okay, and then if the method, let's say the method is executed because the client satisfied all the input constraints, all the preconditions satisfied, and now the object is actually not properly heated, of course, it's going to be the microwave's fault. Okay, so hopefully everything makes sense. You don't lose the big picture. Okay, so in the previous slides, we actually talk about over here. We talk about the general case about clients versus supplier. Also, we draw the matrix. But now we actually adapt this particular concept about client, supplier, and contracts into OOP, especially when you have the client class on the one side and also supplier class on the other side. And specifically in the client class, you're trying to make some method call. Okay, that's the relation between the abstract and also concrete. Okay, so now finally, let me just conclude by defining what the decide by contract is, because now we understand what a client and supplier and also contracts are. So now we can talk about decide by contracts. Okay, what is a good design? A good design should be, because always you have clients versus supplier, you always got somebody who actually defines some service. you also got somebody else who's going to use this particular service. So you always got client and supplier. So that means whenever you got client and supplier, there should be a very explicit and also unambiguous contract between the clients and also supplier. They should be clearly laid out about what the obligations are for the clients and what the obligations are for the supplier. Okay, conceptually, that's really the good definition. There's a proper definition for what a good design is. Okay, and we say that such contractual relation is a specification. So whenever we talk about specification for your method, so that means your method should be properly contracted. You should really define proper contracts for your method and also proper contracts for your class. Okay, so when you conduct software design, you should be guided by appropriate contracts. You should be guided by appropriate specification of what the client should really satisfy and also what the supplier should be satisfying. Okay, again, we just talk about some principles over here. So how can you use design by contracts, how can you use contracts to guide your developments? Number one, the instructions for the client should not be unreasonable, right? For example, you cannot expect a microwave user to actually assemble the parts or to fix the microwave, because that's not their obligation, right? And also, principle number two, for the supplier, the working conditions of their products should not be unconditional. As I said before, you shouldn't expect to heat up some explosive when the microwave door is open and it's not locked, right? So you want to make sure it's fair for both the clients and the supplier. So now, you as a designer, you should really strike a proper balance between obligations and benefits between the clients and the supplier. And of course, this is very general guidance informally. And throughout the course, we're going to see much more precise expression of the contracts using predicates. So when things get to be mathematical, so we have a very precise ground to actually judge whether a particular contract is either too weak, too strong, or is actually fine. Okay, that's something we'll see later. Okay, so now just give you one little quiz over here. Hopefully you wouldn't just see your slide for the answer, right? Think about it if you're just watching the video. What is the obligation of a binary search user? Let's say I'm trying to call a method from the library class, and then the method I'm trying to call is actually a binary search, and the input is simply just, okay, let me outline very quickly over here. Let's say I am the clients. So in my class over here, so I am the clients. And then let's say I'm using some binary search. So let's say I have a utility class over here. I would say u. Okay, I'm gonna initialize the objects, and then I would say u dot binary search. And typically binary search will take a sequence or an array. Let's say array, just to make it simple. Let's say array A. And of course, A should be defined previously. Let's say just an integer, right? Or it can be something that's comparable. Let's say we have simply integer array. Let's say A is assigned to something, right? It's kind of similar to the microwave example. As I said before, in OOP, the principle is really the same. You have to generalize what you learned in the microwave case to this case as well. Okay, so now let's think about this. This particular method call actually suggests some contractual relationship between clients and supplier. And we know that my class is actually clients. So who is the supplier? Utility. Utility over here is the supplier. And for this particular method call, this is the context object, right? It's of supplier type. Okay, so now what should be the obligation for the clients? Typically, the clients is responsible for the input conditions that should fulfill the obligation. So now, what would be the obligation of the clients if I'm going to do a binary search? Okay, hopefully you already know the answer. The array A over here should be sorted. Otherwise, performing a binary search on any not necessarily sorted array is not going to give you the correct result, right? So now the answer should be A is sorted. Okay, hopefully this small example or small quiz over here can actually help you further understand about client, supplier, obligation, etc. Right? So A is sorted should be the answer. Okay, hopefully the illustration makes sense to you. Okay, let me go back here. And then the answer should be the input array is sorted. So upon contract violation, so now we should really be able to judge whether it's a good design or not. Whenever there's any contract violation, it should be exactly one side who breaches the contract, either the clients or the supplier. If there's anything that happens at the runtime, but somehow both the clients and the supplier, either they are both responsible for the error or they're both not responsible for the error, either case, the extreme, they are not good. It should be exactly one side of the party that should be blamed. That's another principle. Okay, so now this design process, by using contracts to guide your design, is called design by contracts. So now the critical question is Java a suitable language for you to express contracts, especially for you to express the obligation for the clients and also to express the obligation for the supplier? The example we saw previously over here, apparently Java is actually suitable for you to actually outline the client class and also supplier class and also method call. So this is something that any object-oriented language should support. So that's not a problem. However, it's really about how can we outline, how can we precisely specify what the pre-state obligation should be for the clients and what the post-state obligation should be for the supplier. Is Java a good language or a suitable language to serve this purpose? That's the question. Okay, so now up to now we talk about all the terminology and also motivation for design and also design by contracts. Starting from the next slides will be part 2 of this lecture. We'll start talking about how we can support design by contracts in Java indirectly.